Sonoluminescence is a mysterious phenomenon caused when ultrasound waves excite a liquid, creating tiny bubbles which emit light when they collapse. The effect is magnified when the bubbles contain a noble gas. The phrase sonoluminescence means sound light. There are various theories about sonoluminescence, none of which have been conclusively proven. Temperatures of above 20,000 K have been measured at the centers of these tiny bubbles. This is hot enough to boil diamond. The phenomenon of sonoluminescence was popularized in the film Chain Reaction starring Keanu Reeves. In the movie, sonoluminescence is used to kickstart a nuclear fusion reaction. Bubbles created by sonoluminescence have been observed generating temperatures measuring in the kilokelvins, or tens of thousands of degrees. The temperature threshold to initiate nuclear fusion reactions is in the millions of degrees, or megakelvins. There is a bit of a discrepancy here, a discrepancy adding up to 3 orders of magnitude. Sonoluminescence is hot, but it's not that hot. Researchers from the lab of Purdue scientist R.P. Taylor claimed that, under sonoluminescence, an acetone-filled vessel emitted neutrons at a statistically significant level, the characteristic footprint of fusion. However, these results have never been duplicated, and were summarily dismissed in an article in Nature in 2006. Taylor's patent for the device was rejected, and an analysis was published by Biener and Joe showing that his data was misinterpreted. The effect of sonoluminescence was first discovered by German scientists H. Frenzel and H. Schultz at the University of Cologne in 1934. They were attempting to accelerate the process of developing photos, but ended up observing luminous bubbles instead. Because the effect was so random and uncontrollable, it was not studied scientifically until much later. In 1989, Felipe Gaetan and Lawrence Crum were able to create a bubble of sonoluminescence that stayed in a constant place. An ultrasonic standing wave periodically generated a bubble and then let it collapse. This was a major step forward, and it allowed the phenomenon to be analyzed in a laboratory setting. It was found that the bubbles were extremely small when the light was released, about a micrometer wide, or around the size of a bacterium. The duration of the flashes are extremely short, even though in aggregate they can be observed with the naked eye. Each flash lasts a few dozen to a few hundred picoseconds, the time it takes for light to move only a few centimeters. Although sonoluminescence is an amazing effect, it currently has no concrete applications and will probably never be exploited for fusion power. Remarkably, there are shrimp that snap their claws so fast that they display sonoluminescence. Scientists with a sense of humor named this effect shrimpoluminescence.